Welcome to the Gaslec podcast. This week's guest is Glenn. He's our electrician that's just joined us. We'll have a chat about some electrical issues and certainly as we move into the future of renewable heating and hot water. But first of all, here's my friend Sean to tell you all about the podcast. Thank you for listening to another Gaslec podcast, the show to help DIYers, new people into the industry, and those who are wanting to expand their knowledge. Each week we'll pick a topic and go into details, and with special guests and listeners' questions answered, we will look forward to some of the conversations. So let's get back to the show. Welcome, Glenn, to the podcast.
Oh, thank you for the introduction.
No
How
problem.
are you?
Yeah, really well, mate. Really well.
Good.
Thank you for coming on. So, for transparency purposes, you'll be joining us in May as our domestic electrician. So we're really looking forward to bringing you on board, mate. I know you personally, and you're a lovely fella. I think you'd be a great fit for our ethos as a company and what we do and how we do it. So really looking forward to that.
Thank you very much.
And certainly getting into, at the moment, we do a lot of obviously gas stuff. We are getting more into heat pumps. We're doing some training at the moment with Mitsubishi for the air-to-air and the air-to-water heating systems. Nice. So the green side of things, which we're going to need a lot more electrics done for. And then obviously there's a big thing in solar, or the big explosion. The cost of materials for solar panels, batteries and inverters are really coming down in price.
Really reduced, yeah.
Really coming down nicely. So getting on board, super excited about that. Obviously there's going to be a transition over the next year or two, coming away from the gas side of things. We're getting a lot more inquiries for the electrical side, the renewable side of heating as well. So electric boilers and that sort of stuff we're getting a lot more inquiries for. So bringing you on board, super looking forward to it, mate. Super looking forward to it. So for the listeners, Glenn, tell us a little bit about yourself, mate.
Yeah, so I've been an electrician in the Midway towns for about 5 years now. I'm mainly specialised in the consumer unit changes, your fault finding, any problems within the house electrically, and then the smaller work of swapping lights over, swapping into 21st century spotlights in the hallways and landings, and, and a little bit of domestic work that comes with that. But all round band domestic electrician in the Midway towns.
Fantastic, awesome. So I've got a question for you.
Sure, fire away.
What's an RCD?
So an RCD. So to anyone else, a residual current device, and that's in simple layman's terms, the residual part is electricity escaping somewhere. So an RCD essentially is monitoring our circuits, sometimes multiple circuits, or just one circuit, and what that's looking for is an equal amount of electricity or going down the line, going down your live conductor and coming back on your neutral conductor. And as long as that is balanced, we're aware that electricity essentially is going where we expect and coming back how we expect it to. What happens with an RCD is it will notice an imbalance if there is electricity escaping somewhere. And in the easiest sense, that could be someone being electrocuted. It could be that we have a fault somewhere and someone's touched a live conductor and they're now going to get a zap. So an RCD would notice that we've got power going down the line, is not fully returning on neutral, and they are designed to trip, and they trip within milliseconds, not seconds, milliseconds, essentially saving a life potentially. So as it stands as regulations, especially on the domestic front, any circuit should be covered by an RCD, and it is solely for that human safety, that personnel safety. Your kids, your mum, your dad, anyone that's within that setting. An RCD is sort of your first line of defence for electrocution.
Yeah, fantastic. So what can help an RCD trip faster and be safer in your home? So
an RCD trips on almost a scientific mathematical basis, but we can make this slightly easier. The more power that is pulled on a line or going down that RCD, the quicker it will trip. So sometimes when we have a fault, that will create more power than what that circuit was designed for. So say most domestic sockets would be found on what we'd class as a fuse, a 32 amp fuse, for ease of listeners. But at full condition, it might pull over 100 amps. And that additional power will allow our RCD to trip quicker. And to improve that number, we can bring in bonding. So bonding is a way of connecting an earth cable or a circuit protective conductor to metallic parts, and that by doing that, it means that if there is a fault, we will try to liven up everything that is now connected to earth, all of our live conductors, all of our metalwork. And by doing that, we would create a really high amp or a really high number, a fault current number. And by increasing that number, we'll get the RCD to trip quicker. So in an easier way of looking at it, the more that we manage to bond, the quicker we might just be able to get an RCD to trip.
Oh, fantastic. So that's incoming services into the house.
Incoming service, your main fuse or your main incoming head that supplies your house with power should have a 16mm bonding to that, and that should always be bonded, and that comes from network, or quite potentially it comes from the network distribution side. So we have a fantastic reading and a fantastic result from that.
Yeah.
And then in addition to that, it's the services that are supplied too, so your gas or potentially oil, and water. All of that has a potential to become live, but also for us, we have the potential to create a better full condition and a better way of tripping an RCD.
Yeah.
Quicker and safely.
So for the listeners, a few years ago, I was working as an electrician as well. So hence the LEC in the Gaslec part. So now we've gone to predominantly plastic incoming gas pipe. And a lot of plastic water pipes now coming in. So do we still need to earth those?
So I think it's quite a contentious point. So by the regulation, if we have an incoming supply that is pulled in by plastic, we're not regulated to do so. However, I would fully emphasise that we would and we should. Yeah. And the simple reason for that is we might come in plastic. However, we can't account for every work that has been done or the future work that's going to be done in the house. And that doesn't stop us connecting metal within the domestic setting. Equally, if you look at a boiler, the majority of a boiler will be metal. I believe its manifold is metal within it and has a ton of metal work. And I believe we have to pipe to it in metal too. So still in my eyes, there is a potential that metal work could become live under fault conditions. So if there was a fault within the boiler, the supply to the boiler might have come in plastic, but the fault within the boiler has now livened the boiler parts up, and any subsequent metal work that's come from that boiler could become live. So I think it is the best practice and the right practice to still bond our metal work, any pipe work, quite frankly. I think there's an old saying of belt and braces, but equally, if I look at it in my own home setting, and I think that's the way that me and yourself look at this when we step into jobs, it's would we be satisfied with that? That's and us being the professionals, I think we have to make them decisions. And as a professional standard, I think that we should continue to bond because there is always the chance to save a life in doing so.
Fantastic. And from like our plumbing and heating side of things, when we fit a boiler, we've got to fit them to a fuse spur. And people say, oh, why can't we fit them onto a plug top? Well, as soon as you pull the plug out, you remove the earth. Yeah. From that point, if you've got a fuse spur, you turn the live off, you've still got the earth connected. Absolutely. So you've still got that additional from the ring circuit up into the boiler, up into the PCB, which goes back to the casing of the boiler, which goes back to the incoming manifold. Absolutely. So you've got that cross bonding of the cold, the gas, and then that helps go back to the heating circuit and go back from then onwards.
Completely.
Fantastic. Well, thank you very much for explaining that, Glenn. So a little funny story. Only a week and a half ago, I got called out to nuisance tripping, and that was the terminology used. It was tripping out. One circuit tripped straight away, and the other circuit tripped after a few minutes. So a little lesson here, actually. Went out to the greenhouse. I was shown it was quite a big property. Out to the greenhouse, and there was an armoured cable coming out of the ground. Right. And it had like a metal like junction box, you know, the circular ones. Yeah. It was all metallic. And with my bare hands, I picked it up out of the mud. It had an open grommet one end. and it had a cut-off bit of twin and earth cable sticking out the end. I picked it up, and it was hot. It was shorting out inside.
Was it really?
And I picked it up. So nothing happened.
Good.
I dropped it back down, and we isolated it off, found it, and then and we made it safe. But simple little things. And there was a good few years ago, I won't mention, it was quite close to where we are here in our office. I went to a house fire, and they had a faulty electrical item that was outside that got wet, and there was a nut. So that was the problem. But inside there was some really poor wiring that was done before they bought the house, and that put a massive fault load. They had the old wiring fuses,
Sure.
and it put a massive fault load on this big spaghetti of wires. That caught fire, but there was loads of rubbish as well under the floor. That caught the rubbish on fire, like from some people have been just throwing old chip papers and whatever else. When they refurbed the house, and then that caught a light, which then caught the floor timbers on fire. And I was sitting there on a Friday evening, and I got a phone call. I was actually coming back from fishing with my son from France, and I got a phone call, and I got home, and it said, "You've got 3 fire engines outside." And just the smoke on the house, the whole house had to be redecorated. It was phenomenal, absolutely phenomenal. So
Sure.
it's and then back then I was doing my electrical, so we moved the fuse box, we put a new one in. Or consuming it, we should call it, but we moved that over and done it all properly for them. So they got all this disconnection, but they didn't have the disconnection at the time.
Yeah, I think the biggest part of that, I think it emphasises is sometimes, especially as the work was done prior to them purchasing the property, is that sometimes, especially in the domestic world, we don't know what we are purchasing. We can see the bricks and mortar, and we look round, and as a prospective buyer, and I've managed to buy my own property. You look at the kitchen and you look at, but it's the hidden work that can be the most dangerous.
Yeah.
It can be the electrical work, and sometimes I think some people are unaware of it. But we as a service, we can go around and do a safety report on these electrical on these properties, just to give that safe mind, because, like you say, you don't always know what's underneath the floorboards and stuff. And luckily, a good electrician can find out faults just by the numbers and his testing, his thorough testing.
Yeah. So that concludes this week's episode of the Gaslec podcast. Thank you very much for listening. Please leave a comment if you can on your platforms where you listen to this podcast, or send us an email with any feedback or questions to podcast@gaslec.net. Have a fantastic week. Take care, guys.